In this lecture, we're going to talk about sprites. What's a sprite? A sprite is a 2D image or animation that we overlay on top of a game to add visual complexity. Most realistic gaming systems have some kind of sprite class structure built into them. If you learn to do that, you've actually made a large stride toward building visually interesting games. In this lecture, I'm going to help you understand a sprite class that we're providing for use in your game. I'm going to show you how to load an image and actually build a sprite. And then I'm going to go through and talk a little bit about some very primitive render methods and update methods for this particular sprite class. A lot of your task in both week 7 and 8 will be to kind of flesh out what I'm going to do here today. So let's go to work. Okay, let's talk about sprites and sprite sheets. So a sprite is a 2D image or an animation that's usually integrated into a larger scene. In games, sprites are used to add visual complexity to a game. Sprites were first developed in the 70s and the 80s, and they just simply corresponded to 2D images that you could translate around inside a particular display. The process of moving around an image inside a display was very computationally expensive, and so people came up with the idea of thinking, you know what we could do? We could develop some special purpose graphics hardware that would just be dedicated to drawing images, no rotation, just translation, just moving the image around on the screen, and speed up that process. And so as a result of that hardware, people said, you know what we should do is we should make lots of images, and we can overlay all those images, and we can make games that look interesting. So notice those early graphics displays couldn't even rotate an image. It was just only translation. Sprites have evolved over the last 25, 30 years to a point where now really just a sprite is just a term used to kind of a logical unit of kind of graphics for organized inside a game. Here you can see down here I've actually drawn a sprite sheet. So this is a collection of sprites. So I've got kind of 3 sprites corresponding to asteroids, and I've got 2 sprites corresponding to a ship. Here's a ship here. Here's a ship with its thrusters on, and I've got kind of 2 little copies of a missile here. So a sprite sheet is really just a collection of sprites. It's a collection of 2D images. It differs from a tiled image in the fact that we don't have to regularly space the images. We can kind of lay the images out however we want. As a result, we want to actually extract those images out. We're not going to just need to have a size. We're going to also need to know the center of the image. You're going to see when we start working with sprites here, we're going to keep track of the center separate from the size. It's not going to be the fact that the center is always kind of half of the size. For Spaceship and Rice Rocks, we're not going to use sprites each, so you're not going to see something like this in the images you load. We're going to load each of these images individually. That gives us the ability to kind of add and subtract images without having to go through and do some editing of the resulting sprite sheet. Okay, before we move on to kind of work with sprites inside Code Sculptor, let's talk a little bit about color and transparency. So up to now, our model for colors has been very simple. Whenever we wanted to specify a color, we specified it as a string. We said quote white or quote black or quote red. We put that in maybe draw a polygon or draw a line, and it made a white line or a black line or a red polygon. It turns out there's a more flexible model for colors. It's called the RGB model. And the idea is you think of a color as being a combination of red light, green light, and blue light. And we kind of model the intensity as numbers. These numbers are going to be in the range between 0 and 255. So we can actually build a color string, an HTML color string that specifies any color in the RGB model, and it's something of this form. It's RGB, parenthesis, red component, green component, blue component. So for example, 255.00 is equivalent to red. If you want to learn more about this, there's a really nice tutorial out here at this particular link. Now, when we're building games like Asteroids and Spaceship and things like that, we need to be able to model more than, say, rectangular shapes and lines and polygons. We want to be able to model irregular shapes. So how do you do this? What primitive we're going to use? If we just always have rectangular images, it seems like we're always going to have kind of rectangular things moving around on the screen. So the trick to doing this is to incorporate transparency into our color space. Here's an example. So this is a little sprite. This is kind of a picture of an asteroid, and you can see it lies inside this rectangular image. And the question that kind of is interesting to ask is, what's the color of this portion here of the image that's outside the body of the asteroid? Well, you might think it's white. I mean, it certainly looks white here. Let's just do something real quick. Let's grab this image. See if I can grab it. We'll move it over here. And what do I see now? Well, I still see the body of the asteroid here. But notice inside this portion of the image outside the asteroid, I see the text behind the image. The image is on top. I mean, the asteroid is clearly obscuring the text underneath. But this portion of text right here, which is inside the rectangular image, we don't see it. We actually see the text. So why do we see the text? It's because this portion of the image is transparent. So we can augment this RGB model for color by adding a fourth number. It's called the alpha channel. And this fourth number says basically how transparent an object is. So in this particular image, it's made up of a collection of pixels. So each pixel has an RGB color. And additionally, it has an alpha value. And that alpha value says how transparent a particular pixel is. So inside the asteroid, alpha is 1. It says it's totally opaque. Outside the asteroid, the alpha value is 0. It says that pixel is totally transparent. And you can actually do this. You can actually do this inside Code Sculptor. There's an option for how to extend HTML color strings to transparency. It's RGBA, red intensity, green intensity, blue intensity, and this is the alpha value here. So this is red with half transparency. So the artist that built the images for Spaceship and Rice Rocks actually built these inside Photoshop. They drew the shapes, and then they went through and set the background to be fully transparent. You can use something like Photoshop, or there's a free open source editor called GIMP that's very similar to Photoshop. There's a simpler one called Paint.net. You can use these and go through, for example, and edit the images we built or make your own images that, again, have kind of a transparent background. Kind of a popular choice of image format is PNG. I recommend that if you're going to go through and make your own images. Okay, that's enough about transparency. You don't really need to understand much except to notice we're going to use transparency a lot in the images we're going to actually incorporate inside Spaceship and Rice Rocks. So let's go on and work with this asteroid now and see if we can kind of build a sprite based on this asteroid. Okay, let's go through and now work with our sprite class to build an asteroid sprite. So here I've loaded into Code Sculptor a subset of the code that we provided you in the spaceship template. So before we talk about the sprite class, I want to talk about an auxiliary class we've built to help organize the information attached to all the images in Spaceship and Rice Rocks. To build a really good looking game, we're going to have lots of sprites, and that means lots of images. And to keep track of all that information, we've built a class to encapsulate all the information relevant to each image. This image info class contains kind of the center of where we're going to draw our sprite, the size of the sprite. Notice these don't always have to be half of each other. There's also a radius field that tells us kind of how big the opaque portion of the sprite is. Like, for example, we want to figure out if the spaceship collides with the asteroid. We don't want to see if the images overlap. We want to see if the opaque portions overlap. So we're going to use circles to do that, and we're going to talk about how to do circle-circle collision in week 8. We have 2 other fields. We're going to have a lifespan. For example, a missile, it's not going to exist forever. It's going to disappear after a while. So the lifespan is going to tell us how long our sprite should exist. And then we have a flag animated, which will help us distinguish if you want to draw an animated sprite. We'll talk about that in week 8. Here you've kind of set the various fields. Here we have some methods for accessing pieces of the image info class. So if we scroll down, you can see what we've done. We've actually set up the information for an asteroid, and we've gone through and loaded the corresponding image out of Google Storage. This is for our blue asteroid. So here do we get to the meat of the matter. This is the sprite class. Our initializer for a sprite, we take things like the position and the velocity, its initial orientation, some angular velocity. We can also give it an image, as well as this image info here, and then we have an option of giving it a sound. Right now we're not going to give it any sound. So we're going to go through here and we initialize all the various fields inside our sprite. And we're going to focus on these 2 methods here. There's a method called draw and a method called update. Draw is going to actually draw the sprite, and update is going to tell us how to update the sprite every time this is called inside the draw handler. So here we see draw it, update it. So let's go through and see if we can kind of flesh out the draw and the update methods so our rock sprite actually does something interesting. So you can see down here kind of the last thing I've done. I've gone through and I've actually created this a rock sprite. Its initial position is the center of the image. It has no velocity. It has orientation is 0. Its angular velocity is 0. We're going to say we're going to use the asteroid image, and we have asteroid info. So let's run this real quick. And then what comes out is not very inspiring. Here's our sprite. It's a red circle. When we did that is kind of stub art to kind of make sure things are running when we get started. And it's not surprising that we have a red circle because our draw method for a sprite says take the radius of the circle that approximates it, draw it at the position, and this is what we see. So let's go through kind of a three-step process to get this working a little bit better. So the first thing is let's go through and see if we can actually get it to draw the image for the sprite. So I'm going to comment out our draw circle, and let's see if we can put in another operation. We're going to say draw image. And what do we need to draw? Well, we need to draw the image attached to the sprite, so that's self.image. We need to draw, let's see, take the center of it. So we're going to say self.image center. And then we're going to take self.image size. And where do we want to draw that? We want to draw it at the position of the sprite. So we'll say self.pos. Then we'll say self.image size again. And what should be the orientation of the sprite? Well, we've got it. We've got it. It's self.angle. So let's crank that up and see what happens. Oh, look at that. I caught an error before I ran it. Canvas. All right. There it is. We've drawn our asteroid sprite. So let's go through now and modify update to make it do a few interesting things. So these asteroids are supposed to be tumbling through space, so let's make that image rotate. So to do that, I'm going to need to modify the update method. And I'm going to do is I'm going to change the orientation image. It's self.angle here. We're going to change it using the angular velocity. So this is pretty easy. I could say self.angle plus equals self.angle velocity. Is that the right field again? Make sure I get it. Is angle velocity. Okay, let's go down here to the initializer. And let's see, the initial orientation is 0. That's fine. But let's figure out a good value down here for the angular velocity. So the angle's in radians. So that's 2 pi. So that's 6.28. So let's make it kind of maybe rotate kind of 1 revolution a second. So there's roughly 60 calls to draw in a second. So if we made this 0.1, I think this should rotate about once a second. So let's give that a crack and see what happens. There it is, rotating very nicely. Okay, let's finish off our example here. Let's make the asteroid move. So we know how to do that. So we did this from Pong. We've done this a fair bit. I could say self.pos of 0 plus equal self.velocity of 0. And I could say self.pos of 1 plus equals self.velocity of 1. And then we need to give it a reasonable velocity down here. That's what this entry is. So maybe like 0.3 and maybe 0.4. All right, let's give it a crack. And there it is. Our asteroid is spinning and now moving along. So this is a single asteroid, single rock. This is what you have to do for spaceship. When you get into week 8, we're going to have to keep a collection of these rocks. Okay, that should be enough to kind of get you going on working with sprites. It's worth some time understanding the structure of the class. You'll have to build some more methods for it. But again, I think don't be daunted by the size of the code. Just focus on the step-by-step description and the mini process, development process, and I think you'll be able to tame the complexity. Okay, I'll see you back in a little bit and we'll talk about your spaceship project more.